So let's try to model a small staircase tower. We have in front of us a small setup with 4 columns and a few floors which have been entered. You can see the 2 landings on each side. The distances are that in this direction it's 5 meters and it's about 3 meters in this direction. Because the reason for taking 3 meters is because you will have 2 stairs, one going up from there and then the other one going up to the other landing from there. And I want to keep each one of them at about 1 meter wide, at least. So keeping them 1 meter wide and also within the limits of this would require about a 3 meter depth in this direction. So let's start by modeling the stairs. So we don't have a special icon over here for modeling stairs, but we know that we have beam groups, and we can use use any one of these commands actually, then convert the beam group to a stringer. So let's use the normal beam command and go in there. I've created the points. So this distance is about 300 millimeters. Then there's the width of the stairs is about 1 meter. This is the center. And then from the other side also there's 300 millimeters, and then it's a 1 meter width for the stairs which is going up. So my first piece which I want to enter over there is, it'll start from there, and then I can just hover over the very same point and say dx minus 300 to create a beam in that direction. Now I can double click on that, and I'm going to convert that into a UPE 200 section. And I will also change the type to a stringer so that it's differentiable from being a normal beam. And once I do that, I can see that the color also changes. So on the top over here, you have the column beam, horizontal bracing, vertical bracing, truss, purlin, girt, etc. But these are not the only 5 beam groups. You can have multiple, you can have other types, like if you were to look into this, you already have those column beams, horizontal, vertical, girts, and purlins, but then you have trusses and stringers and handrails and column lacing and crane girders and all sorts of different types which you can use. So we're going to use the stringer type over here. Now, once I have this one, I can continue to enter the other one. Let me first try to align this. The way I want this to be placed is I want to rotate this to the other side, and I want to place it like this so that the back side of the channel is coming at that point. My other point for the other side will be over here, and the back of the stringer will be coming at that point as well. So there'll be a clean distance of 1 meter between the two. So this is the way I want them to be oriented. Now continue with the command. Let's select this point, hover over the same point. I want to go down from here. I want to go down and basically create the symmetric something which assume a landing is over there, and it's going to mirror that. So this distance between the 2 landings is about 3 meters, because this hole is 5 meters. So I'm already going to take up 300 millimeters for this one, and then there'll be another straight 300 millimeter beam. So my distance for that point, if I just hover over that and say enter, should be, if I use the direct entry method, I can say minus 2,400 from here in the x direction, 0 in the y, and in the z direction I can go minus 2,500, which is the height of that floor. So when I do that, immediately this stringer is created, and there'll be a small piece coming out, and it'll be aligned with this landing over here. Now, what I can do now is I can select both of these, right click and say match elements, and select the first one, and immediately the second one becomes similar to the first one. I can continue with my command. I can just hover over this point, click on that, hover over it, and say dx minus 300. This will give me the final little piece. I can select them again, use my match elements command, use this to be the main member, and my basic first side, or the right side of these staircases has been finalized. Now let me select all these 3 which I've just created, And I want it to, the width to be 1 meter. And this is the midpoint. This is the midpoint. So let me just mirror it around this midpoint. So let me right click and say copy and say mirror and select this point and the corresponding point at the other side. Or maybe I should not work like that. It's a better idea to go to the floor, this section over here. And here I can see those midpoints more clearly, and it's always better to work in the plan view. So now that I have my 3 stringers selected, I can go to the plan view at 2500 millimeters. And remember that these are the 2 points. The other side will be over here, the other side of the staircase. And this is the center point. So all I need to do is just say copy special, mirror, select the center point to be the mirroring line, and say run. And when I do that, I can just make this bigger and come back and see that just like the back side of the channel was aligned with this point, similarly the back side of the channel is aligned with that point, and it's looking the other way, which is exactly the way I want it. Now I can continue by finishing this. What I can do is I can create the connections over here. So I have different options for that. I can use the beam-to-beam end plate connection. For example, I can use the stiffen end plate connection. I can use the fin plate connection, or I can even use the beam-to-beam angle cleat connection. So let me just quickly go through all of them. And so if I choose this as the main beam and I choose this to be the secondary one and right click, I immediately get an angle cleat connection over there. This is nice. This is okay. It's been coped, as you can see. The bottom flange and the top flanges have been coped. I can use this. It's okay, but I'm not going to prefer to use this. I'm going to undo that. We can also use the stiffen end plate, for example. I just select the main beam and the secondary stinger, and the stiffen end plate connection is created. Because of the channel, you only have bores on the inside and not on the back side. Once again, I can do that. This is fine. This is actually very nice. But I could also use my fin plate connection, for example. So what I can do is I can go to my fin plate connection, select the main beam, select secondary beam, and then right click 3 times. I'll give the reason of why we're doing that. And once we're done with that, because the backside is taller than this one, we need to modify the parameters a bit. So I've got one saved for the stringers. I can just load them, apply them, and now I have a perfect fin plate on the backside. The reason we chose a UPE 200 profile over here is not necessarily because of statical restrictions. The reason actually has more to do with the stair treads, which are going to come over here, and they need a certain width. So using very small stringers, or say maybe statically, even a UPE 140 or 160 section might do. But normally with staircases, we tend to use slightly larger ones so that there's no problem with the treads. So this is another option which we can use, the fin plate option. It depends on us. Like I said, we can use any one of them. So let me continue by applying the same one to the other side. Right click 3 times and then calling the appropriate preset for that. Now I've chosen these to be my connections with the main beam because of ease of erection as well, and because also the loads are pretty small. These are not heavy loads. 2 bolts are more than enough to take whatever 20 people are standing on that staircase. Now, obviously, these two need to be fitted to each other. And for that, we have this fitting connection command over here. If I were to press shift and open it, there is the option of having 2 plates between the fitting, or a single plate, or no plate at all. So in our case, we don't want any plate between them. So we're just going to select the no plate option and then just choose these two. And as you can see, they've been fitted together. Over here also, we can select this 2 over here, and we can go to the bottom side, select them, and as you can see, they've been fitted to each other very conveniently. So at this point, basically, I'm ready to enter my treads for this staircase. And if I were to go down I have this command, the stringer holes command over here. The stringer holes command is actually used for both for creating just holes, but also for creating threads as well. Now, in industrial buildings, two types of threads are typically used. You can use checkered plate, folded checkered plates as threads, or you can use gratings, and it will depend on the projects. So let me just create some. Let me select the command, and what it asks you to do is select the two stringers. And the moment you do that, the steps are created, and they're created with certain defaults. And right now the default is the checkered plate option, and we can modify that from the inside. So the checkered plate option looks like something like this, that it's basically a folded plate which goes along the stringer. I can press M, enter as always, and I can have my grating option as well. And I can press apply, and then the grating, this symbolizes the grating basically. And it also uses, if you go to the detailed option over here, you can have certain, you can have pre-fed grating threads inside. So for example, here is a famous company. We can use their threads, and that factory thread will be created, and the holes will also be created according to that. So you need slot holes and normal holes to actually connect these threads, and they have a certain distance between them, and this distance is not arbitrary. You cannot just, once you select a particular thread from the catalog, then that particular thread has a certain size, and the holes need to be created exactly at those points. So what the command will do for you, it will, if you go inside, it offers you these options of how to place these steps, whether you want the difference between the lengths to be given to the top and the bottom, or equally distributed. The three options over there. You have the option of telling it what the landing will be like. So if the landing has a grating on it, you can say that this one could be 30 millimeters. If the landing is say checkered plate, then it could be something a lot less, maybe 3, 4, 5 millimeters. So you can enter those, and then it'll try to adjust the steps accordingly. So right now it's the grating option. So you can use all these options to create your threads as you want. But the point which I'm trying to make over here is that creating a staircase tower, you need to basically set up the landings first, and then create these points to ensure that you can basically create the stringers. Then just use the direct entry method to create the stringers where you want them. Connect them at the ends by using any one of the fin plate or the stiffen end plate or the angle pleat or any one of those options which we have available for floor beams. And then use this command over here, the stringer holes command, to create either grating type or checkered plate type threads. Now, of course, once you're happy with the way your stairs are looking, you can continue to add the handrail, for example. So I'm just going to add the handrail on this side, right click, and a basic default handrail is created. I'm going to go enter and choose my macro presets for the rounded pipe one and modify that into that. And immediately I get a very nice looking handrail for my stringer.